All right. Good morning, guys. Today's lesson is 3.3, proving lines are parallel. All right. Now, remember in 3.2, our lesson was about properties of parallel lines, okay? When we're given two parallel lines, remember we learned about same side interior angles, alternate interior angles, alternate exterior angles, and corresponding angles, all right? And this is when two lines are parallel, okay? Well, today it's almost like we're working backwards. We have to prove that, that the angles are either supplementary or congruent to determine if the two lines are parallel. All right. So like if you look at theorem 3.4, it says the converse of the corresponding angles theorem. Okay. And the theorem states if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So here, if we say that angle 2 is congruent to angle 6, then line L is parallel to line M. Okay. Part 1, it asks us to identify the parallel lines. It says which lines are parallel if angle 1 and angle 2 are congruent. Justify your answer, okay? So here we have angle 1, and here we have angle 2, okay? So we can state that angles 1 and angle 2 are corresponding angles, okay? They're corresponding angles. And if corresponding angles are congruent, because it tells us right here that angle 1 and angle 2 are congruent. So if angle 1 is congruent to angle 2, then line A is parallel to line B by the converse of the corresponding angles theorem, okay? If angle 1 and angle 2 are congruent, then that means that L and M, or A and B, are parallel, okay? The reason why it wouldn't be L and M that are parallel here is because angles 1 and 2 both lie on line M, okay? Now let's look at the second question. It says which lines are parallel if angle 6, so here, all right, so here we have angle 6 and angle 7, all right? So angle 6 and angle 7 are corresponding angles. And if angle 6 and angle 7, or if they are congruent, if angle 6 is congruent to angle 7, then line L is parallel to line M by the converse of the corresponding angles theorem, okay? I'm not going to write all that out. But if 6 is congruent to 7, then line L and M are parallel, just because they are corresponding angles, all right? All right, here theorem 3.5 is the converse of the alternate interior angles theorem. If two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel, okay? So if angle 4 is congruent to angle 6 here, then lines L is parallel to line M, all right? And then theorem 3.6, the converse of the same side interior angles postulate. If two lines in a transversal form same side interior angles that are supplementary, then two lines are parallel. So we know that, excuse me, that same side interior angles are supplementary, and which means that they have a sum of 180 degrees, okay? So we could add the measure of angle 3 plus the measure of angle 6 and get 180, all right? For example, let's say angle 3 has a measure of 60, and well, let's do 120, because 6 or 3 is actually an obtuse and 6 is acute. So let's say the measure of angle 3 has a degree of 120 and the measure of angle 6 has a degree of 60, okay? And then we could add 120 plus 60 and get 180. So we know that these two lines, or these two angles, are supplementary, so we could say that line L is parallel to line M. All right, theorem 3.7, converse of alternate exterior angles theorem. If two lines in a transversal form alternate exterior angles that are congruent, then two lines are parallel. Okay, we know that alternate exterior angles are congruent if the lines are parallel. So what we're saying here is if the lines are congruent, then, or that the two lines are, or the two angles are congruent, then we know that the lines are parallel. So if angle 1 is congruent to angle 7, then line L is parallel to line M, okay? In the next part, we are going to use our different terms that we have learned and to solve this. And so what we're going to do is we're going to solve for the value of x that makes the two lines parallel, and then I'm going to justify each step, okay? So here we have 2x plus 9 and 111, all right? So here they are inside of the parallel lines on the left side of the transversal. So here we have same side interior angles. And same side interior angles are supplementary. So I have to add 2x plus 9 plus 111 and set it equal to 180. And that's because that's the definition of supplementary angles. And that's the same side interior angles, okay? Because same side interior angles are supplementary. All right, now we just got to combine like terms. We have 2x plus 120 equals 180. Subtract 120 from both sides. So we have 2x is equal to 60. Divide both sides by 2. And x is 30, okay? X is 30. Now, it just says, what is the value of x? So we're done here, okay? If it asks us to find the missing angle, you would just substitute 30 in for x here, which would be 2 times 30, which is 60, plus 9, 69. And then you could check your work by adding 69 and 111, and you will get 180. All right? Now here, what type of angles do we have? Okay, they're both on the left side of the transversal. 55 is in the exterior, 3w minus 2 is in the interior, but they're both on top of their lines, so they're in corresponding positions. So these are corresponding angles, and so corresponding angles are congruent. So we could set 55 equal to 3w minus 2. And then just solve. Add 2 to both sides. And we set them equal because corresponding angles are congruent, okay? Add 2 to both sides. 55 is equal to 3w. Divide by 3. And w is 19, all right? If we wanted to solve for this, to solve for the angle, we would just substitute 19 in for w. So we have 3 times 19, which is 57, minus 2, which gives us 55. And we know that is correct because corresponding angles are congruent. And if they are congruent, then the angles are the same. All right, part 3, two-column proof. Two-column proof. It says writing proof of the converse of alternate exterior angles theorem, all right? So we're given that angle 1 is congruent to angle 7, and we want to prove that lines L and M are parallel, okay? So we got to start with what's given, okay? And what's given is angle 1 is congruent to angle 7, all right? And that is given. And if you look at angle 1 is also congruent to angle 3 because vertical angles are congruent, okay? And then 3 and 7, angles 3 and angle 7 are congruent because they are corresponding angles, and corresponding angles are congruent. And if corresponding angles are congruent, so if 3 and 7 are congruent, then remember that is the converse of corresponding angles. So we could say that line L is parallel to line M, and the reason is if corresponding angles are congruent, lines are parallel.